Here, I'll say it at the beginning, yeah, it's rare we're going to see a pure break in here. Like workday is the closest thing to breaks we're going to see.
You don't want me to drop this.
So, all right, nope. But again, it's your call. I can't help those things. All right, let's do this. Equations with radicals. Okay, no fancy formulas. No fancy things with the graphing calculator. We're just going to do some basic algebra stuff today, so I should be right in most of your wheelhouses. So, to cancel a radical, take it to the reciprocal power. Now, that's going to be an option. We'll see that on several of these. So, solve the equation by showing work. Remember to check for extraneous solutions. In other words, you did all the math right, but the answer still doesn't work. I will give some hints on some areas that could come in handy or that you don't really need to worry about it, but we'll get to that when we see them. So, first thing, you've got to make sure as much as you can for two things. Number one, your radical is alone on the side if it can be. And then number two, is that we most definitely only want one radical per side. Because if we have more, oofda, that is going to be messy. And something you should be able to avoid every single time. That's not going to be one of those, hey, here's the Hardy weird problem. Nope. Nope, nope, nope. We're going to be able to do that for sure. So most of these are already going to be set up for that. And that's a good thing. So here, okay, there's my radical. It's by itself. That's cool. So we got to undo the square root. So we'll square each side. Yes, even the side that does not have a radical. It's still algebra, and we still got to do the same thing both sides. So, goodbye radical. Oh, but hello x squared. Oh, do we know what's coming yet? We have x squared. I am a big fan of x squared being positive. So here, I know it would be simpler with one step to just bring it over, but I'm not going to do that. I'm bringing everything to the x squared side because I want it to stay positive. Now at this point, you have options. If you want to go to the duct tape of all quadratics, go to the quadratic formula, as long as you know the formula, go for it. This is factorable. So let's just say I go old school. I'm not going to get fancy. I'm like, well, multiplies to 1 and adds to 2 Hardy. X plus 1 squared, or x plus 1, x plus 1. But don't stop. We're solving. So when you solve, you get an answer. Now here's going to be my kind of warning on the extraneous solutions. The generic rule is you don't want a negative under the radical, because if you do, that's going to cause I, and normally we don't get I's for answers. So if something's going to cause I, it's no solution. The other one is going to be, when you take the square root of a number, it could be 0, it might be positive. It's never going to be negative. So if you plug the x back in and it causes the solution side to be negative, that's also a big red flag. Let me show you what I mean. So if I plug -1 in, okay, I don't even need to look at this right now. I'm going to on this first one, but here's why I say I didn't even need to look at this. You square thing, sir. The square root is never going to be a negative because I'd have to have I. These aren't the same thing. That doesn't work, and since that's my only answer, that's going to be no solution. So, a couple of situations I'm going to keep myself aware of. Well, Hardy, what if I did this whole thing and it was the unit test and I just left that and I circled -1? way to here, so you get those points, but you're going to get the answer wrong. We don't want to lose points and half points when we don't have to. So that's the danger. Is this going to happen a lot? No. But especially if it's a negative, take the time to check it for a minute. All right, let's play around with some things that can throw us for twists. Alrighty, what's going on here? Okay, we know this. Okay, 1/2 exponent over root, it's the square root still. So I'm going to do the exact same thing that I just did over here when it was a square root. Those are going to cancel. Just leave me with the stuff underneath. Don't square that stuff. It's not where we want to be. And I'm going to play this game exactly the same way. This stuff all goes to the x squared side when I'm doing this. So minus the 7x, add the 10 over, because we're going to the other side. And now it's your choice of ways to get to the answer. I guess you could even plug that in on y equals in the calculator if you wanted to and look for zeros, but I think that's going to take you a lot more time than dealing with one of these other options. So let's see here. Multiplies to a positive, adds to a negative, means they're both going to be negative. Adds to 10, multiplies to 10, adds to 7. 5 and 2. Set those equal to 0, or if you do that in your head, just change the signs. So now I'm feeling pretty good about both of these, because 5 and 2 aren't going to be negative over here. That's a good sign. And if I just take a minute, I'm like, okay, 7 times 5 is 35, minus 10 is 25. Square root of 25 is 5, okay. But even if I just check to make sure this isn't becoming negative, that's probably going to be enough. 7 times 2 is 14, minus 10 is 4. It's positive 4, almost 100%. That's going to work for both. Occasionally, can you get one of each? You could, especially if it's negative. So just be alert. Just be alert. Okay. Number 3. Oh my gosh, there's radicals on both sides. That's okay, one per side. These are the ones you're going to hope show up on every problem. Because if you square root right away, we're back to algebra 1. So, yep, add that over, add the 3 back, we get 4, we double check. 4 minus 3 is positive, 9 minus 8 is positive, I'm happy, okay. So see, I'm not going to be the terrible brute that's going to say, you better check every single one. I'm just making sure they're coming out positive, and then I'm calling it good. The only thing you have to be cautious of, and this really is more of a careless thing and a speed thing than anything else, okay? Kind of the same idea that we just did here, except it's a cubed root instead. Watch the exponents or watch the roots. I'm just going to cube them both since it's cubed roots. Everything else is the exact same thing. And now it's just little stuff. Minus that over, and I make sure I don't get lazy and say, oh, it's just x equals -1. No, it's not. Divide by -1. 4 minus 1 is 3. Yep. 3 times 1 is 3. Yep. That's really the only check I'm making. So, what we've seen so far, we've had one answer a couple times, we've had 2 answers, we've had a no solution. 5 is about as nasty as this is going to get. Because, here's why it's going to be nasty for some of you. I will say this in advance, trying to save some of you for when you get here. Where is my little post-it? There it is. There it is. If I said nothing right now, I am pretty sure I would see that from a lot of you on this. Well, I just squared Okay, and I squared negative 10. It's positive 100. No, 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 no. You're losing your middle term. Huh? So, you need to do one of two things to make sure that is not you. You either need to write it out completely and then FOIL it out. Bless you. Because there is going to be a middle term. It hasn't changed. For those of you, I've talked about the shortcut for this before too. Okay, the shortcut is if you have a binomial squared, you square the first term. You multiply these two things together. K times negative 10 would be negative 10k, and double it, multiply it by 2, which would be negative 20k, and then square your last term. I get there the same way. If that is something you're thinking, I'm not going to remember that, Hardy, I'm just going to go back to it, then write it out. We got to get to this part. And just like we did on number 1 and number 2, wherever k squared is, that's where the party is going on. And so everything needs to get to where k squared is. They're on opposite sides. You have to do opposites. And now we're back to the same thing that we were on number 1 and number 2. Your choice on how you're going to tackle this. Because you have 3. Factor, quadratic formula, graphing calculator, find zeros. Those are the 3 options. Hardy is going to keep immediately going to factoring because factoring is the fastest. Even though the others are perfectly usable. Multiply to a positive, add to a negative. They both have to be negative. And if I have to play with the calculator to find numbers that are working with 60, play with the calculator to find numbers that go with 60. But I need to find a pair that are going to get me to 16, and I'm not there yet. 6 and 10. Bingo. So I start to look at these, and I go, okay, let's do this. Let's try 6. Okay, say that's 24. 40 minus 24, 60. That's good. 6 minus, 6 minus 10 is negative 4. The square root will never equal a negative. 6 doesn't work. It wasn't even negative, Hardy. What the heck? It caused a negative, though. If I do 10, 40 minus 40, okay, that's 0. 10 minus 10, that's 0. That's fine. That works. So we're just checking to see if your answers cause negative issues. They won't always mean that it'll always be a negative if it's not going to work. So you can start to see where the details come into play. Let's see here. I won't kill you at 2 more of those. I will with 1, though.
Yeah, let's not do 6. I'm out of room.
Well, I was about ready to say I wasn't going to do 8. Can we if I eliminate 8, can we squeeze 6 over to here? I'm hoping. Let's try, because this is the one I want to chat with here. This is when we talk about your radical has to be alone. That m has got to move before you square this, or that would be an utter mess to deal with. That would remind me of one of the problems a college professor gave us one time and told us we had to multiply out. And I'm like, ugh. So move the m over. We got to get rid of the square root, but unfortunately for us, that means we have to FOIL this out. Shortcut does wonders. Just saying. Square my first term. Take the product of these two and double it, so negative 6m doubled is negative 12. Square my last term. Using number 5 as my prime example, the m's coming over by subtraction, the 4's being added over, so minus another m, plus another 4, Go to your favorite of your three options. Product is positive. They're going to be the same sign. That sign. What multiplies to 40 and adds up to 13? 8 and 5. M equals 8. M equals 5. Why can't it be 5? Bingo! Bingo! So now, no, that's where some of you go off the rails. You watch and listen during this, think you've got it, and then you don't practice, and you're like, wait, what the heck just happened? And I'm like, okay, last one. Already it's a fraction. Don't care. There's still one radical per side. We're going to be all right. Ew, again, Hardy, though. There's a fraction. Okay, let's fix it. If we don't like the fraction, do what we normally do to get rid of fractions. I mean, hey, there's no squared here, so I'm happy about that already. I'm actually going to find a problem I don't have to factor. Oh, let's see here. I only got b's over here, so let's add that over. And divide by 5. Does this work? That's positive. That's positive. We're happy. Okay. So again, if we're okay with our foiling or using a special case, if we're decently okay with factoring the quadratic formula, this shouldn't be a huge issue. So, now, before the moaning and groaning comes, I'm going to tell you why the back of this page is being done. I think you probably know. So, the front is you solving some of these equations with radicals. If you need more room, I've got paper. I can get you some more space to work with if you don't want to use some of the shortcuts and things. So the front, you're going to have the little puzzle at the bottom, which I will again share the answer to the puzzle so you kind of know where you're going with that. Hardy. Why, Hardy? Just why? 2 reasons. Exponents will be reappearing very shortly. Hint, hint, we got to remember our exponent rules. And as we head towards Unit 3, which is going to get into some other rational things with equations and graphing, this will show up again. That's why I'm hitting it now, so don't ignore it going, well, this isn't the lesson, I'm not going to do it. If you do, you're not going to feel happy about it later. So, just saying. Just saying. So, as you get yourselves rolling here, how do I want to do this? I'm going to do this. I'll have some of you do it later, and it's going to save me. It is better. Oops, hang on a minute.